Hi kids, today we are going to review angles and talk a little bit about shapes. So we'll be talking about acute, right, obtuse, and straight angles. You'll remember from class that we had our hands together at one point. This is an angle of 0 degrees, and as I raise my hand I'm in an acute angle, which is between 0 and 90 degrees, and then I get to a right angle, which is exactly 90 degrees. I'm going to have to turn around. So a right angle, and then as I go this way, my angle is greater than 90 and between 90 and 180. And so this is acute, 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 right, obtuse, 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 straight. And a straight angle is an angle of 180 degrees. So you remember that acronym was that AROS, and that stood for acute, which is between 0 and 90, right, which is exactly 90 degrees, obtuse, which is 90 to 180, and straight, which is exactly 180 degrees. That straight line is a angle of 180 degrees. So if I had a point right here and I started here, and let's say I watched the sun rise and then go all the way down, that sun would have gone 180 degrees up from here, which is 0 degrees, up to 90, and then over to 180. So AROS, acute, right, obtuse, and straight. And again, we can model that with our hands. Let's go over a few things we need to understand. So a point is just a point. We could have a point in space, like where is this pen in this three-dimensional room? Or I could actually say where is this point on this whiteboard if I broke this up into equal grids. So we have a point, we have lines, which is something like that between 2 points. We have a line segment, which is just the space on a line between 2 points. We have a ray, and rays are important especially because when two rays meet at a vertex, they form an angle. So a ray is a line that starts at one point and goes in one direction. It could be any direction, and oftentimes these things, these points have names like A and B, or N and M, or point C, which we'll investigate in a minute. So here are kind of some things we need to know. A point is just a point, like it says. A line is a line that goes between 2 points and extends apparently infinitely forever, we can think about. A line segment is the space between 2 points, and a ray is a line that goes in one direction that begins at a point. So, a few other things I want you to remember from class are perp and perpendicular lines, which are lines that form a 90-degree angle, and this symbol here, this square, is a 90-degree angle. And so if that's 90, and that of course must be 92, because again a straight line is 180 degrees. So perpendicular lines are like T's. This is also one. A capital T is a perpendicular line. There are a lot of letters that have perpendicular lines. And then we have parallel lines, and we often put shapes into categories by whether they have perpendicular or parallel lines, or both, or one of the other. So a parallel line, or two parallel lines, are lines that go in the same direction forever, meaning that the distance between here and here is the same. So parallel, I like to remember parallel as the two L's in parallel are parallel, right? Two L's in parallel are parallel. So if I wanted to get more specific, I have a meter stick, and if I could hold this steady, we know that the meter stick is the same width all the way across it. So if I can hold this steady and not mess up, I can kind of draw two parallel lines. We did this in class with a protractor actually, but we can see that I think this is about 3 centimeters, the width of this, about 3 centimeters there, about 3 centimeters there. So these lines are parallel. They go in the same direction forever, and they will never meet because lines like this might meet at some point. You can see they would run into each other or intersect each other. Intersect is when two lines cross each other, like in the middle of an X. That part right there is an intersection. And so we put shapes in categories often based on whether they have perpendicular or parallel lines. So let's talk about a few shapes. A square or a rectangle. And we're going to assume that I'm drawing these perfectly. All these lines are straight. And we're going to assume that this is 90 degrees. That's 90, that's 90, and that's 90. So that's just a regular square. This squared off again is the symbol for 90 degrees. A square is a rectangle. It's a special case of a rectangle. It has two sets of parallel lines and two lines that meet at a perpendicular point. So a square has 90-degree angles, has 4 of those, whereas a triangle has 3 angles, and those angles are kind of a little half a moon there that indicate that's not a 90-degree angle. This is probably acute. This is probably acute if I had a protractor, which is that tool that we used in class that kind of looked like this. It had 0 all the way to 180 over here, and then on the inside, or on the outside, depending on which one you used, we learned that we could measure angles, for instance. And of course 90 degrees would be right here, because 90 is half of 180. So if I think about my shapes, we actually put triangles in certain categories. We're not going to do that today, but if you think about this shape, pretend it's perfect. And 90 degrees, 90, 90, 90, or 90 times 4 is, 4 times 90 is 360, so 360 degrees is 4 90-degree angles added up. Well, if I cut this in half, diagonally, I would create 2 triangles, one here and one here, and now I would have still these 90 degrees, but a couple of these. So a triangle has 3 angles that add up to 180 degrees, and 180 is half of 360, so it kind of makes sense if we have a shape that has 4 90-degree angles and we actually cut it in half and make 2 shapes that have 3 angles apiece, those add up to 180. Let me get my computer back on. Okay, now we are actually going to move on to angles and how we can draw them and sort of figure out which angles are what. If we want to add or subtract or find missing pieces, we can do that. Remember, the tool that we use to measure angles is called a protractor. In your homework this week, there are some drawn protractors that asks you to give the angle. Remember, if an angle is between 0 and 90, looks something like this, or it could look like this. Angles don't always have to be this way. We're kind of right side up. They can be upside down. This angle here is definitely less than 90, because a 90 degree here would be somewhere like that, maybe, and we can see that this is an acute angle. Again, if I start this way, acute, 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 right, 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 obtuse, obtuse, and straight. So that will help us whether we're using the inner or the outer scale on the protractor. Actually, now that I think about protractor, it's going to come up next week. Might be a little bit of work on it this week, though. So, an angle is formed when 2 rays meet. Here's a ray going this way. There's a ray going this way. This angle is formed depending on how I draw those rays. This part here is called the vertex. It is where two rays meet. We often label the points. We'll just use ABC right now. And I can tell again that this is maybe a 45-degree angle. It's about halfway between 0 and 90. If 90 was about here, that looks about halfway. So if I was going to name this angle, here's the symbol for that, angle ABC, or I can write this as angle CBA. The important thing to notice is that the vertex is always the middle letter. Oftentimes you'll see the outside letters as capital, and if they want to name this angle X, we can do that too. It would just be angle X. It's all the same angle, either ABC, CBA, or angle X, depending on what you want to call it. This kind of becomes important in a minute when we're trying to add and subtract angles. So let's do another one. If I want to draw an angle, of course if I wanted to draw an angle at a certain degree, I would use a protractor. We did that in class. Angles, this would be an obtuse angle. I can kind of see that it's bigger or greater than 90, but definitely not a straight line. So let's just do DEF. Give you a second to think about what is one name you could come up with to name this angle. Well, we could call it angle Y. We could call it angle DEF. DEF. Could also call it angle FED. So FED, DEF, or simply angle Y. And the important thing again is that the vertex, which is the point where the two rays meet, is always in the middle, and that way there's no confusion over which direction, because the vertex where they meet tells you that line D, or the line with point D on it, meets the same line, well, not the same line, but the line F with point F on it at letter E, which is the vertex. So, okay, a couple more examples and then that's going to be it for this week. I don't have a timer going today, but I'll try to keep it short. Okay. In your homework this week, you'll be adding up certain values or angles, or finding a missing angle. So let's say that that's going to be angle M. We'll call this A, B, C, and D. So let's say that angle M equals 82 degrees, and angle angle N equals 50 degrees. I could ask, so angle M is the same as ADB, angle N is the same as BDC or CDB. Again, we just talked about that. So if M equals 82 degrees, and angle N equals 50 degrees, what would this entire angle be here, we could ask. I realize this drawing doesn't really reflect that, but what would this entire thing be? So what would angle ADC be? Angle ADC equals 82 plus 50, and essentially we would have this entire angle ADC be 132 degrees. And in fact, if I was actually doing this to scale, this would be more like, oops, that. Because angle 132, that looks like this could be a 132 degree angle. So again, angle ADC would be angle M plus angle N to give you this bigger angle. Like I'm opening a computer, let's say. I get a laptop open this much and I stop. What is the angle there? what angle, if I open my laptop, does my laptop open or turn on automatically? Maybe it's not when I just lift it, but maybe it gets to a certain angle and then I bring it that way. So all kinds of applications. Let's do one more. Angles are all around. They are used to build maps. What angle am I going to be going if I go to walk down this hill or mountain? All kinds of ideas around angles. So let's try another one. And this will be it. I'm drawing these up, or I guess we'll call it upside down. SVUT. SVUT, and we'll use X and Y. Lowercase x is 70 degrees. That's kind of sloppy. 70 degrees. So, what is angle SVU? Well, SVU equals 107 degrees. So, we know that this angle from here to here, SV or SVU, is 107 degrees. We know that angle X is 70 degrees. So what is angle Y? What can we do there? Is angle X smaller than our entire angle? No, angle X is just a part of it. It looks like it's 70 degrees part of it. So if I know that this whole angle SVU is 107 degrees, I know part of that is 70 degrees. Angle Y has to be the difference. So I can think about what 70 plus what will give me 107, or 107 minus 70 is going to give me the same difference, angle Y. So 7 minus 0 is 7. 10 tens minus 7 tens, or 10 minus 7 is 3. Of course, I can't really subtract a 7 from 1, so I could cross that out, move that one over there. So angle Y is not a question mark anymore. Angle Y is 37 degrees. So that's going to be it for this week. I think there's 6 sheets to look at, and I do think that protractors is next week. Probably work with protractors a little bit, and maybe a little bit of area, and then it's going to be happy summertime. So I hope you're all doing well, staying safe, and enjoying the people around you, and taking care of yourselves. Have a good evening.